We're going to start this lesson by practicing factoring quadratics, because it's going to lead us into our new topic for this lesson. Now, what I'd like you to do is go ahead and factor each of these three quadratics on your own, and then once you've done that, continue watching here to see how we do those. So to factor our quadratics, we look to see what adds to the middle number and multiplies to the last number. So in the case of this first problem, I'm looking to see what adds to 3 and multiplies to a negative 28. That's going to give me a positive 7 and a negative 4. So it ends up being x plus 7 times x minus 4. That is the factored form. That's where we're going to, and that's where we stop. Now for our second one, we have x squared minus 4. Sometimes this sort throws people off because there is no x term in the middle. But the fact that there is no x term tells us that it's 0. So in this case, we're going to add to 0, and we're going to multiply to a negative 4. And so thinking about different ways we can multiply to get us a negative 4, that's got to be a 2 and a negative 2. So it's going to be x plus 2 times x minus 2. All right, and then finally, we do the same thing here for our x squared minus 25. For that one, I'm adding to 0 and multiplying to negative 25. Think about the different ways I can get to the negative 25. It's got to be a negative 5 and a positive 5. And so that's our factored form there. One little note before we continue here. The order in which we write our parentheses does not matter. So for instance, on this last one, if I had written x plus 5 times x minus 5, that would have been perfectly fine. These are the types of problems that we're going to be leading into today. Notice now we're no longer factoring a quadratic. We're actually factoring a quartic because we have the power of 4. Now we're going to be looking at a very particular technique today that relies on the fact that this first exponent is twice what the second exponent is. Thinking back to our quadratics, that's what we had there as well, because in a quadratic, you start with an x squared, and then you have an x, which is to the power of 1. So again, in those, the first exponent is double the second exponent. Because of that pattern, these are actually going to behave just like quadratics. So in order to factor this quartic, I still need to see what adds to 3 and multiplies to a negative 28. And just like we did in the last problem, we know what that's going to be. We're going to have x minus, or x plus 7. And we're going to have x minus 4. Now, if I multiplied that out, though, that would give me the x squared at the start and the x at the middle, instead of x to the fourth and x squared. So the way that we can make this work is we actually make each of these inside the parentheses into x squareds. Now if I multiplied that out, the x squared times x squared would give me x to the fourth. And they would add to the 3x squared in the middle. And so it's the same process as what we used on factoring quadratics, except now we have to actually have a particular sign on the x, and a particular exponent on the x there. All right, so now that we've gotten to this far, the one wrinkle that this can now give us is that sometimes these can be factored even further. And in this case, notice this x squared minus 4 that it left us, that can be factored. And it can be factored because it's an x squared. So we're going to go ahead and factor that part now. The x squared plus 7, it does not factor, because we can only factor it if we're subtracting a perfect square. And the x squared plus 7, it's not subtracting, and it's not a perfect square. So 2 reasons why it can't work there. But the x squared minus 4, we did factor that one in the first round, and we saw that factors to be x plus 2 times x minus 2. So this would then be considered the fully factored form of this. Now take a look at that second one. Start thinking through how you'd approach it, what you need to do in order to factor that. Hopefully right away you're thinking, okay, well I have to add to the middle number and multiply to the last number again. And so that's what we're going to do first. The only difference is that each of these parentheses is going to start with an x squared instead of just starting with an x. So then I think what multiplies to a positive 18 adds to a negative 11. That's going to be a negative 9 and a negative 2. Now that I've done that, because they're x squareds, I do need to look and see, can these factor anymore? So first up, looking at the x squared minus 2. In order for me to be able to factor that, I would have to be subtracting, which I am, and I'd have to be subtracting a perfect square. Now 2, though, is not a perfect square, and so that one is not going to factor any further. Next up, the x squared minus 9, it is subtracting, and the 9 is a perfect square. So yes, we can factor that one further. So let's go ahead and do that. The x squared minus 2, remember, that did not factor, so it stays the same. And then the x squared minus 9, I'm thinking what adds to 0 multiplies to negative 9. It should be 3 and negative 3. So x plus 3, x minus 3 there. And then that one is now fully factored because, again, the x squared minus 2 did not factor, and both of these that I just got, they're just x's, no x squareds. So they're not going to factor any further past that. All right, so here's 2 more problems. Based on what we just did, I'd like you please to go ahead and try factoring each of these on your own first, and then once you've done that, follow along with the video to see how you're doing on it. Part of that learning process is doing it on your own, and then checking it. All right, so for this first one, we need to add to 13 and multiply to 36. So I start thinking about, okay, what can I get to multiply to 36? And as I go through those, I can actually come up with, it's going to be a 4 and a 9. So it's got to be x plus 4, x plus 9. And since we're dealing with x squared and x to the 4th at the start, each of those parentheses starts with x squared. Notice whatever that middle exponent is, that's the one that's going to be on each of our x's inside the parentheses. Now we look at each of those to see can they factor further. So the x squared plus 4, remember it needs to be x squared minus a perfect square. Well, this one's plus. It's plus a perfect square, but it's not minus 1, therefore it cannot work. The x squared plus 9, I look at that as well. Again, that one's plus, so it cannot factor any further. And so that one now is fully factored. It's done. Now let's take a look at the second one here. X to the 4th minus 13x squared plus 36. Well, it looks very similar to the first one, right? And it is going to be very similar when we factor it as well. Both parentheses still start with x squareds because that's what our middle exponent is. And it's still going to be a 4 and a 9. The difference, though, is that in order to multiply to the positive and add to that negative, both of these are going to be minuses. And remember why we couldn't factor either of those? They're both pluses. Notice these are both minuses now. X squared minus 4, it needs to be minus a perfect square, and it is. So we're going to be able to factor that down further. So that's going to become x plus 2 times x minus 2. Then we take a look at the other one, the x squared minus 9. Does that factor? Well, again, it is minus a perfect square, and since it is x squared minus a perfect square, we can factor it. We saw this one on the last set. It's x plus 3, x minus 3. And now looking at that answer, notice they're all x's, no x squared, so definitely we can't factor any of them any further, so that one is done. That is the fully factored form. So notice the process here. We factor down using the same thing we did with quadratics, but then we need to look at the result and see if it can factor any further. And so just when you're starting to get your head around x to the 4th and x squared, now I'm throwing x to the 6th and x to the 8th at you. But it's actually still very doable because notice again it's following that pattern I talked about where the first exponent is double the second exponent. The same is true here. Because of that, they behave just like quadratics. And so, for the first one, I can still just say what adds to the middle number and multiplies to the last number. And so, in this case, it's going to be a negative 10 and a negative 5. Now the question is, what's in front of those? It's not a plain old x, because this is x to the 6th, not x squared. In order for that to be an x to the 6th, this is my exponent. It's got to be x cubed. So each of these parentheses starts with x cubed. Whatever that middle exponent is, that's the one that goes inside your parentheses. Now we take a look at each of those parentheses. You notice they're both x cubed. They're not x squared, so no, those will not factor any further. We don't have ways to factor the x cubes right now, so that is done. Now we go on to the next one, x to the 8th and x to the 4th. because it's x to the 8th and x to the 4th, that tells me that each of my parentheses, when I factor this, is going to start with x to the 4th. Now I do my add 2, multiply 2, like normal. What adds to negative 4 multiplies to negative 21. There should be a negative 7 and a positive 3. And again, taking a look at each of these, can they factor down? No. The x to the 4th minus 7, we could actually try to get creative here and actually make it into something when we have the x to the 4th. You know, if it was x to the 4th minus a perfect square, maybe, but we're not going to be messing around with those. So since it starts with x to the 4th, that one's actually going to be called done. So that is your final factored form for that. Now that we've done those other problems, these are the last two you're going to be seeing on this lesson. So what I'd like you to do then is try doing each of these two problems on your own paper first. Then once you've done that, resume the video, and let's check and see how well you've done. All right, so for the first one here, we have x to the 10th and x to the 5th. Because the first exponent is twice the second exponent, we can do our normal add 2, multiply 2. And then when I do that, each of my parentheses is going to start with x to the 5th instead. That exponent on the x in our factored form is always the same as your middle exponent again. All right, so now I need to figure out my two numbers. And those are the two numbers that add to negative 6 and multiply to negative 27. Now, as you go through the different ways to multiply to negative 27, you should then come up with a negative 9 and a positive 3. Now we look at each of those and see, can they factor? Well, the x to the 5th minus 9, it's close because it is minus a perfect square, but it's x to the 5th, not x squared. So no, that cannot factor further. For the same reason, this one cannot factor either, because it's x to the 5th. So that's our final answer for that one. Now, on to the second. In this case, since it's x to the 4th and then x squared, each of our parentheses are going to start with x squared. And then I need to see what multiplies to negative 49 and adds to a positive 48. Well, that's got to be the 49 and 1. Oftentimes we have a little blind spot when it comes to the times ones because we're often told to disregard them. But when factoring, we definitely need to keep them in mind. So it ends up giving us x squared plus 49 and x squared minus 1. Now again, we need to take a look at each of those two sets of parentheses, see if they can factor further. So x squared plus 49. The 49 is a perfect square, but it's adding it, not subtracting it. And so that one cannot be factored. How about the x squared minus 1? Well, it is x squared, it is subtracting, and 1 is a perfect square because 1 times 1 would give us 1. So that one is factorable. So the x squared plus 49, that one stayed the same because it was not factorable. But the x squared minus 1, that becomes x plus 1 times x minus 1. That then is as far as we can factor it, so that is your final factored form there.